here you have, we've got your two physics teachers here. You've got the superior physics teacher right here and the inferior physics teacher, Mr. B, behind the camera.
Hi.
So I just wanted to start with something. Depending on when you're doing this, this lesson, we may have talked about this yet or we may not have, but here's the thing that I want to think about. Let's imagine that we had two cars and we wanted to graph, on the x-axis we graphed how much time we watched the cars, and on the y-axis we graphed the displacement of the cars in meters, right? So maybe come over here. So here's my thought. If I had this car and I had that car, I probably should do the different colors so it matches the cars we do in class. So if I had this car, I had this car, Mr. B, which one do you think is going faster?
Well, based off of the slope of the lines, I would say that the one with the larger slope has the larger velocity.
Okay, why would the slope indicate velocity?
Because slope is rise over run, and the rise of this graph is displacement, and the run is time, and velocity is displacement over time.
Ooh, that's good music. All right, so so what you're saying is if we pick 2 points, like my rise here is a distance and my run here is a time, so we can say velocity is distance over time.
That's exactly what I'm saying.
And you're saying that the red car is going faster than the blue car then?
That's exactly what I'm saying.
Okay, all right, interesting. So we could say that the slope of a displacement graph... Stupid music.
That's
So
all right, just roll with it.
We could say that the slope of a displacement graph gives us velocity.
Yes.
All right, now, the question that we're going to ask in the lab today is, what happens if the velocity is changing? So, jeez. So I got this car that's got a fan on it, all right? And if we watch it, right, the fan is going to give this car a constant acceleration. So you're going to see it's going to start pretty slow, but it's going to be getting faster and faster until it hits the wall. All right, so that's what we're going to look at today. We're going to watch this car for different amounts of time. We're going to keep the acceleration constant, and then we are going to, watch the distance, right? So we're going to watch this car for different amounts of time and see what distance it travels in different amounts of time. So at this point, it's probably going to be a good idea to open your Word document, and the first question is asking you for the independent, dependent, and control variables. So again, like I said, we are going to change the amount of times that we watch this and see what happens to the displacement, right? And we're going to keep the acceleration constant. So with that in mind, go ahead and fill in the table for what types of variables we're looking at in this lab. So just looking at your Word document, right, I want you to tell me what was the independent variable. So again, what are we controlling? And you'll just type that there. Your dependent variable, you'll type that there. Oops. Type that there. Your control variable, you'll type that here. Okay, so that's what I'm asking you to do for the first part. All right. Here, are you on?
Nope, now I am.
All right. So what we're going to do here is every second, Mr. B is going to tell me when to make a mark. And then we're going to measure how far it goes each second. All right?
3, 2, 1, 0, 1, 2, 3, 4, 5.
All right. So, okay, let's see here. Let's see what we got. So in the first second, it looks like we were at, I'm going to say, about 40 centimeters, so that'd be 0.4 meters. And then we're at, what, 1.07 meters? 2.34 meters? 3.66 meters? Oh, 1, 2, 3, 4, 5 point.
And students, notice that we're actually measuring that instead of just guessing what it was.
5.26 meters. All right, so you're going to want to put these in the trial 1 section of your lab. Yep.
Okay, here we go. 3, 2, 1, 0, 1, 2, 3, 4, 5.
What is that? Oh, that's right, isn't it?
Yeah,
Yeah, that's right. Okay, all right.
Relatively.
Okay.
The other ones came
That's
onto
right.
this.
I forgot we added a meter.
Well, the other ones came onto that last meter stick,
Okay.
but that's pretty close.
Are you still recording?
Of course I am.
All right, so at 0, we're at 0. Point, what, 5.3?
Yeah.
1.47.
47.
2.53.
Sure. 6.9, I would say.
3.69.
Yep.
4.87.
Sure.
I don't know if you can read my chicken scratch here. There you go. That's trial.
Number.
Whatever trial this is.
This is trial. Insert your own number. All right, this one's for the record books. 3, 2, 1, 0, 1, 2, 3, 4, 5.
That was an awful rough run. I don't know. It ended at the right spot though.
Yeah.
All right. So 0 is 0. What you got for 1?
53.
Oh.
Oh yeah, it's
yep.
right here in the black.
Yep.
What, 35?
Okay. 230.
Yep.
341.
Yeah.
1, 2, 3, 4, 498. 497.
497.
All right. There we go.
Trial number, whichever.
All right, so at this point, right, you should have this table filled out and you should have calculated your averages. And I've made a graph in Desmos and I've got them here. We're not going to do a best fit line because if you look at that, that doesn't look like a line. It looks a lot more like a curve. And you know from algebra that the most basic curve is a parabola. So we're going to put the general form of a parabola in for our best fit curve. So what I'm going to do is I'm going to type y equals ax squared, and the way you make a squared is caret above the 6. So squared plus bx plus c. Then I'm going to add all these sliders, and what I got to do is I just have to keep playing with these sliders until I get a graph that seems to go around most of the points. See, there's a little bit of trial and error you got to do with this. So I'm getting pretty close. I would say I'm very close with that.
That looks pretty good.
Did I mess it up? There we go. That's pretty good. So you can see that I've got a curve here, right? And then just a reminder about how to put this into your document. So we're going to do two things, right? We're going to go to this button up here. We're going to copy this link over because that's, if we need to ever edit it, we're going to copy the link and I'm going to paste it, which is just Control V on your keyboard. And then the other thing I'm going to do is I'm going to say export image and I'm going to copy that image. Uh-oh, what have I done wrong? Do you know what I've missed?
I know what you missed.
What did I miss, Mr. B?
You did not label your axes.
Yep, we got to say the x-axis is my time in seconds. My y-axis is my displacement in meters. All right, there we go. Now I better copy it again, copy the link again to make sure I've got the changes. So copy the new link, then I'm going to export the image, right click, copy image, paste it. All right, so that's my graph. And then it's going to ask me, what is the equation of the best fit curve? Well, I used the form y equals ax squared plus bx plus c, but I got to